What's up, everyone? Welcome to the session. How are you guys doing? Welcome, one and all. My name is Anoop, and this is Vedantu's YouTube channel. How is everyone doing? All good, people? What's up? Hi, Devida. Hi, Katyayani. How you doing? Hi, Durga. What's up? I'm good. I'm good. How are you guys doing? I am amazing too, Kushi. Thank you for asking, and I hope that all of you guys are doing good too. Hi, Rituraj. Hi, Disha. Hi, Joseph. What's up? How you doing? I think you were the winner for the last quiz time. No, good to know, buddy. What's up? Thank you, Keshav. New haircut. No, I know it exactly. Hi, Rupsa. What's up? How you doing? Welcome to the session, people. I hope that all of you guys are doing good. My name is Anoop, and this is Vedantu's ninth and 10th English YouTube channel. I hope that all of you guys are taking care of yourself and also preparing for your final exams. How many of you guys are happy that the dates are out, or how many of you guys are sad that how many of you guys just want the exam to be over with? That tell me the truth. How many of you guys are here who just want to get it over with once and for all, your board exams, and then see what happens next? Yeah, Alina. All right, only Alina. What? That sounds like a lie, people. That sounds like a lie. All right. Anyways, yes, people, we'll have a lot of mentee quizzes today. Don't worry about it. So, people, today we'll be revising the entire chapter of work, power, and energy, or work, energy, and power, whichever order you want to put it. But we will be doing the entire chapter. We'll be solving a lot of quiz questions after every single topic that I'll be doing today. So we'll be talking about everything from the very first topic, that is what is work, until what is energy, what is power. All of the concepts that is related to this chapter, we'll be studying that. And yes, we will be having mentee here and there in the middle. So make sure that you have logged into your Mentimeter as well. I'll tell you the code in a minute. Once we start, I'll tell you what is the code as well. So once again, welcome. Now stay till the end, because every single thing that I'm going to be talking about today is going to be important. If you have any sort of confusion in this chapter, this is your chance to get it cleared once and for all. Right? So people, are you guys ready for the session? Shall we begin? Give me a quick, oh yeah, yeah, people. Are you guys all ready? Thank you, everybody. Thank you. I know, right? Haircut. All thanks to the barber, the barber. All right, guys, awesome. Okay, so people, let's start the session with a positive note. The code for today is this. The code is: your limitation is, it's your imagination. It's only your imagination. How much how much limitation you put your imaginations, that is how much your limitation is going to be. So always aim for the highest, aim for the first. Like there's this saying by APJ Abdul Kalam sir, that aim for the first, only then at least you'll get into the top 3 or top 5, something like that. So make sure that you put your imaginations high. Make sure that you tell yourself that yes, 99% or 95% is possible. Only then at least you'll get 92%. Don't aim for 80%, because then you'll end up getting 75%. So aim higher, so that at least you get a little bit lower than that, but it's still something that you can be proud of, right? So with that said, let's begin with today's session. These are the topics that we'll be doing today. So without wasting any more time, listen carefully. We'll start with work, we'll solve some numericals, power and energy and its numericals, potential energy and numericals, kinetic energy and work energy theorem, different forms of energy and their conversions, and conservation of energy. Now these are the topics that we've already done. We have done about 6 sessions of this chapter. If you haven't watched any of those videos, make sure that you watch that as well. If you have any confusions, that will clear it up. Right, anyways, work. Now, in the chat box, I want you guys to tell me, what is work? From what you have understood. Now, this is not a new concept. You've been studying about work, I think, from 7th standard. So tell me, people, according to you guys, what is work? In the chat box, come on. Yeah, today was your video. Alright, tell me what is work, people, in the chat box. Anyone who can define what is work. Whoever defines what is work will get one hats off from me. One clap. Don't you want it? So work is done when there's displacement. Alright, force applied is what is called as work. Alright, Bhagavi, anything else? Kiss and bath. I'm good. Alright, work is done when there's displacement. Is there any other definition that you can give me? Force applied, and displacement occurs. Work is work. Right, that's the best. Work is said to be done if there's force and displacement. Alright, interesting. Now that's pretty much accurate to what I'm about to say. Says work is said to be done when, as some of you guys said, when there's displacement. For example, let's say Keshav is standing here and he's pushing a box. Now, when he's trying to push this box, what would he do? He would apply some force. What is force? The push or pull that he does. Now in this case, he's pushing, so basically there's work done, or he's applying a force to the box. And what's happening to the box? The box is changing its position. In other words, it is getting displaced. And this displacement is when you say, when there's displacement, that is when you say that there is work done. Now let's say that Keshav picks up the box and keeps it on a table. Here also, once again, he's applying a force, and more importantly, there's displacement happening. The box is getting moved or getting displaced from one position to another, and that is when people work is said to be done. Okay, let's take another example. Let's say that I'm trying to push this table. All right, I'm giving everything that I can, but then I don't see the table moving at all. Now, according to physics, can you say that work is done in this case? Let's say that I'm trying to push this table, or let's say that I'm pushing the wall. I'm giving my everything to the wall. I am sweating. I'm doing everything that I can. But then according to physics, can you say that work is done when there is pretty much no displacement happening? Exactly no. You guys know about it. Why not? Because the displacement is zero. When there's no displacement, according to physics, there is no work done. Now, you might be spending energy, you might be sweating, you might be doing everything that you can, but then there is no work done because there is no displacement at all. Absolutely, guys. So we can say that work is said to be done when basically the amount of force, the amount of force that you apply, or the magnitude of force, whatever is the amount of force, is a 10 Newton, 20 Newton, that is when you can say that work is done. And secondly, more importantly, when that force applied creates a displacement or produces a displacement, that is when you can claim that work is said to be done. Now, for example, when I'm pushing this wall, let's say that I'm putting like 100 Newtons of force. Even if I'm putting 100 Newtons of force, if there's no displacement, then I cannot say work is said to be done. Why? Because there is zero displacement. No matter what I do, no matter how much I sweat, no matter how much I scream and be like Rafael Nadal every time he hits a ball, it is still not going to work. Why? Because the displacement is said to be zero. Simple? All right. Now, let's get back to the topic. If I have to talk about the formula for work done, work done is equal to force into displacement. For example, a box. So this is the initial position of the box. This is the final position of the box. And what is the displacement? That is nothing but S. So F into S is nothing but work done. Simple. But in your ICSE, it's not as simple as that, because you have something called as an inclined plane. But if you're asked to define what is work done, you can write it like this: the amount of work done by a force equal to the product of force and the displacement in the direction of force, that is when work is said to be done. The amount of work done by a force is equal to the product of the force and the displacement in the direction of force, that is when work is said to be done. And the formula W is equal to F into S. Simple. So was it good? Now, this is where it gets a little complicated. Not too complicated, but a little complicated. Let's say that I am pushing a box this time. All right, this is me trying to push a box, right? Look at me, all weak, trying to push it, right? Now, here, since let's say that I don't have the energy to lift it up and keep it on that higher ground. So what would I do? Being a smart student, being an engineer, what would I do? I would keep an inclined plane. I'll just keep a small plank, and then I'll try to push the box up. Now, in this case, is there a displacement happening? Yes or no? In the chat box, people, is there displacement? Yes or Hindi? Hey, my Hindi is very bad now. All right, now tell me this: is there displacement or not? In this case, is there displacement or not? Absolutely yes. You can see that the box is getting displaced from the bottom position. It's moving up. Yes. Am I applying a force? Once again, yes. There's force put in. Now the weight of the box is acting downwards, but the force is acting towards the side. I mean, from the side, I'm applying a force. But the displacement again is not happening straight, but rather it's happening in an inclined direction. It's not exactly straight. Now, let's say that there's a box here, and I'm applying a force from here in this direction. Right, force is applied. Basically, it's what to say? You can say that it's parallel to the floor. It's parallel to the floor. I'm applying a force, a straight force I'm applying. But the displacement of the box is happening this direction. This is how the displacement is happening. Now, the displacement is in this direction, which means that, see guys, for all the ICSE students, you guys know that when there's an inclined force like this, you can resolve these components into two kinds. You have the parallel component and you have the perpendicular component. How many of you guys know about this parallel components and perpendicular? Don't say that you do not know. Yeah? You guys know about it? Yeah, cos theta, sin theta. So basically the parallel component is this, which is you can call it a sin theta. This will be sin theta, and the that is a perpendicular component. The parallel component would be cos theta, right? Now, which means that the displacement, I'll just take this, basically the force is applied in this direction and my displacement is in this direction. Now, tell me this, guys. Because the force is applied in this direction, in the straight direction, which of these components would or is parallel to the force applied? Is it the perpendicular component, or is it the parallel component of displacement which is in parallel with the force that I'm applying, which is in direction, which displacement do you think is in the direction of the force applied? Is it the perpendicular component or is it the parallel component? Is it sin theta or is it cos theta? Exactly, the parallel one, which is nothing but s cos theta. And that's why, people, the formula of work done when you talk about an inclined plane is not just W is equal to F into S, but rather it is F into S cos theta, because here you're considering the angle between the displacement and the force applied. See, there's a clear angle that is there, right? You'll see that there's an angle theta. That is the angle that is formed between the force and the displacement, and that angle is what is considered when you talk about force being applied or the work done on an inclined plane. So the formula then gets slightly changed from F into S to F into S cos theta. Now the thing is this, people, the value of theta, that is angle, whatever the angle cos theta is, that is something that would vary in different cases. But what you have to understand is this, people, right now in ICSE you don't have you have only the the standard values like cos 30, cos 60, cos 90 or cos 0, but you don't have the other standard values. You don't have it right now. But in your 12th grade, in your 11th and 12th grade, you will be studying more about it for all the students. 11th, CBSE, ICSE, no matter which syllabus you guys follow, in your 11th and 12th you'll be studying a lot about that. For now, just remember this, guys, that W is equal to F into cos theta. Now, for example, people, let's say that the force, let's say there's a box and I'm applying a force of F in this direction and the displacement is also in this direction. So people, let me ask you this question. What is the angle between the force and displacement over here? What is the angle between the force and displacement? In other words, what is theta? What is the value of theta here? Come on, people, come on, quickly. 180 degrees, dead. Avinash, sure. 0 degrees, 0 degrees. Anda will be the angle. 90 degrees, Agrawal. Sure, it will be 0 degrees. Think about it. What is the angle between the force? If it's in the same direction, if F and S is in the same direction, what is the angle? It's 0 degrees, right? So cos 0 is nothing but 1. So remember this, guys, cos theta, that is cos 0, is equal to 1, and hence the formula will become W into F into S. So this is how you actually got the formula F into S. It's actually derived from this main formula. That is how you got the formula, that is W is equal to F into S. Because in majority of the cases we consider the force and the displacement to be the same direction. But that's not always the case, because sometimes, like I told you, in the case of an inclined plane, there's a clear difference, that is, there's a clear angle formed between force and displacement. At that time, it's going to be a little different. Right? I hope you understand this, people. I hope you understand this. Is it clear, people? Is it clear so far? Is it clear? Everyone understood this so far? Yeah? Everyone? Exactly. It is. Clear, people? Awesome. So that is it, people. So let me just quickly sum up the first part of the topic. So if you talk about the amount of work done along an inclined plane, there are three things you have to consider. The magnitude of force, definitely. The displacement, the magnitude of displacement also. But along with that, the angle formed between force and displacement is also a very important component. That is why the formula will become W is equal to F into S cos theta. This is the formula that you must remember when you talk about work done, when you talk about an inclined plane. Now, one thing that I would like to say is this, guys. Work done can be positive, negative, as well as zero, depending on what? Depending on the force, the direction of force, and the displacement. For example, if the direction of force and the displacement is in the same direction. For example, let's say that let's say Joseph is pulling the box up. Now when he's pushing the box up, he's applying a force in this direction, and the displacement is also in the same direction itself. It's getting displaced from here to here in the same exact direction. Hence, at that time, work done is said to be positive. That is, W is equal to F into S. It's going to be positive work. Zero is when the force and the displacement is at an angle of 90 degrees. That is when we can say that the work done is said to be zero. When the work done, for example, okay, let's say that I'm pushing the wall. I'm trying to push a wall, or let's say that I'm trying to push a box or something. The force and displacement, if it's at 90 degrees to each other, in that case, the work done is said to be zero. You know why? Because when this is the case, so what is cos 90? Anyone who remembers what is the value of cos 90 here? Anyone? Cos 90, cos 90, cos 90, 90, 90. Anyone know? Exactly, Piraki. Cos 90 is 0. So if you put it on the equation, W is equal to F into S cos theta, because cos 90 is 0, it will be cos 90 F into S cos 90, and cos 90 is 0. The whole thing would be 0. That means the work done would be 0. So when the displacement and the force applied is at 90 degrees, in other words, it's perpendicular to each other, in that case, work done is said to be 0. And when is work done negative? When it's in the opposite direction. For example, let's say if we talk about, let's say that you're applying a force and the box is still falling down. You're applying a force, you're trying to apply a force, but the box is still falling down because of gravitational force. Displacement is in this direction, but the force that you're applying is in the opposite direction. In that case, work done is said to be 0 because it's opposite direction. So it'll be negative work done. When the displacement is in the opposite direction of the work done to the force. You can also give the example of friction. That is also negative work done because frictional force is always in the opposite direction of the motion. So displacement will be in this direction because, for example, when you apply a brake, let's say that you're driving a car or a bike. When you apply the brake, the car does not go backward. It doesn't go backward. It will still move a little forward and then stop. So displacement is in this direction. The frictional force is in the opposite direction. So in that case, the work done is said to be negative. Right? So yeah, people, that is what I would like to conclude with. So with that said, people, let's get into the let's get into the mentee meter. Before that, one last thing. So SI unit of work done is nothing but joules. You already know about that. So 1 joule of work is said to be done when 1 Newton of force is applied and the displacement is said to be 1 meter. So that is when if you want to define 1 joule of work, you can define it like that. 1 joule of work is said to be done when a force of 1 Newton displaces an object by a distance of 1 meter. Alright, so that's how you define it. CGS unit is nothing but erg. So erg, again, the CGS unit of force is dyne, and the CGS unit of distance is centimeter. So it will be dyne centimeter, which is nothing but erg. And work is not a vector quantity but rather a scalar quantity. Now remember this, people, all this plus minus 0 and all, it does not talk about the direction. No, it only talks about at what what is the displacement and what is the force, what is the direction of displacement and force. But work itself is not a vector quantity. Remember that it's a scalar quantity. So this negative sign does not represent the direction but rather represents at what is the direction of displacement, not the work done. Work done does not depend on direction, it only depends on the magnitude of force and displacement, not on direction at all. Alright, so with that said, people, I know that you guys have been waiting for the mentee now, so let's do the mentee first. Where is the mentee? Quickly join the mentee, people. We have 6 questions for you guys. All of them are questions. All of these are problems. So get your open a new tab and enter the website www.mentee.com, mentee.com, and enter the code 62426696 and join the mentee. Quickly, everyone. Bala, it's all I have. So switching between 2 sessions, I know all of you guys are like full on multitaskers. So vector into vector equals scalar. Yeah, Pinaki, that is, you'll study about that. That is like your cross products and dot products of 2 scalars and 2 vectors and all that. You'll study that later on. In your 11th and 12th, you'll be studying that even more. I think in your ICSE there's a little bit of it, but in your 11th and 12th, you'll be studying that in detail. Yeah, let's go, guys. Let's go. Come on, the code is this, people, 62426696. So quickly join the mentee meter. Once you're in, do let me know, people. The SI unit, sir. SI unit of Vedantu. Vedantu does not have an SI unit. It is a dimensionless quantity. To keep change reactions under control, and the nuclear reactor one uses All right. Now we use control rod, I guess. No, Lakshya, if I'm not wrong. All right. Let's go. Let's go. Let's go. Come on, quickly, quickly, quickly. Everyone, join the mentee meter. Once you're in, do let me know. All right. So everyone's here. I'm going to start the question, people. So the first question is going to be a simple one, but yes, requires you solving every question. So here it is, people. Calculate the work done when a 5 kg weight is lifted 10 meters vertically. That's the first question. Again, take acceleration to gravity is 9.8 meter per second squared, not 10, 9.8 meter per second squared. All right. Second part of the question: a car is moved on a rough road through 30 meters against a frictional resistance of 75 Newton. Calculate the work done over there as well. So there are two parts in this question. You can suppose to calculate what is the work done. For the first one, there's a object of 5 kg being lifted up to a height of 10 meters vertically, and there's another car which is moving on a rough patch it moves about 30 meters against a frictional resistance of 75 Newton. Find out what is the work done. Options are 300 joules and 225 joules, 328 joules and 2000 joules, 490 joules and 2250 joules, 225 joules, or 3500 250 joules. Let's go. Come on. Thank you, Bhargavi. Thank you for helping me out. Naam hi nahi dala. It's all right. In the next, before the start of the next question, you can put up your names. Don't worry. 24 of you guys went with option number C, and that is apparently the right answer as well. Brilliant, people, brilliant. Proud of you guys. I know that you guys are amazing and you guys are proving it once again. So let me just quickly solve this question for all those who have a confusion in this question. Let me just solve that for you guys. So first of all, they've given you for the first part of the question, they've given you the mass. They've not given you the weight. They've not given you the the force. They've given you the mass. They've also given you the displacement to be 10 meters. First of all, the formula is F is equal to work done is equal to mass into force into acceleration. Okay, wait. One second, guys. Oh my god, what am I writing? One second. Yeah, people. Sometimes no. Okay. Work done is equal to force into displacement. Alright. Now, force is equal to mass into acceleration. Alright, force is equal to mass into acceleration. Now, because see guys, the thing is that they have not given you the force. They have not given you the force. Instead given you the mass of the object. So first of all, guys, calculate what is the force. Now, you can do it this way, but you do not know the acceleration. So rather than doing it like this, find out the weight. Because what is weight? Weight is nothing but the force by which Earth is pulling an object towards the center. So what is the formula of weight? Weight is equal to mass into acceleration to gravity. So mass is what? 5 kg. Acceleration to gravity is 9.8. So you get it as 49 Newton is what you're going to get. Once you get that, put it in the first equation, that is work done is equal to force into displacement. So work done is equal to 49 into displacement is 10. So you'll get it as what? 490 joules. That is the answer for the first question. For the second part of the question, again, it's direct substitution over here. Second part of the question, they've given you the displacement. They've also given you the force as well. So again, work done is equal to 75 into 30. So multiply that. How much are you going to get? I think you'll get it as 2250 joules. Right? So that is the answer for the first question, people. Sorry about that. Instead of saying it as work done, instead of saying it as force, I told it as work done. Sorry about that. Anyways, so that is the answer for the first question. It's 490 joules and 2250 joules. Simple. Alright, now, I hope you guys got this, people. First question, such an easy question. With that said, let's get back to the topic. Alright? Let's study a little bit more and then again come back to the course. Power. Now, what is power? In the most simplest term, power is nothing but the rate of doing work or work done per unit time. So the formula is quite simple. Work by time is what is power. The rate of doing work or the work done per unit time is what is called as power. The SI unit is nothing but this. Work done SI unit is nothing but joules. SI unit of time is nothing but seconds. So joules per second, which is also called as watt, named after James Watt. So you have power. The SI unit of power is nothing but watt, and the definition of power is nothing but rate of doing work or work done per unit time. So let's say that someone is pushing a box. So all this while, all we were bothered about was the force as well as the displacement, the magnitude of the force and the magnitude of displacement. We did not consider the direction. Okay, yeah, we did consider the direction of the force and displacement, but we did not consider the direction of the body itself, and more importantly, we did not consider the time. But if you were to consider the time taken for the person to do that particular task, that is when you say that the power is said to be high or low. So basically, people, when the work done, if let's say there is two different people lifting up two different weight. Let's say that both of them are lifting the same amount of weight. All right, both of them are lifting up, let's say 100 kgs. Both of them. Whoever does it faster, would have more power. That is what it means. Lesser time, more is the power, because it's indirectly proportional. Lesser the time, more is the power. More is the time, lesser would be the power. So here there's a simple example given. So the force applied by the person, the work done is said to be 60 joules, and he's doing it in 3 seconds. So what will be the power? It will be 20 joules per second, or 20 watt. So that's how you calculate it. So remember this, people. So if they ask you questions like this, who has more power, whichever person takes less amount of time, that person would have more power, because power is indirectly proportional to time. It's indirectly proportional to time, not directly proportional. All right, so it's indirectly proportional to time. That is, S is nothing but seconds, so it is indirectly proportional to time. So remember this, guys. Lesser is the time, the more is the power. More is the time, lesser would be the power. So that's how you do it. And again, power is also a scalar quantity. The formula is quite simple: work done by time, and the definition of power is nothing but work done per unit time, or the rate of doing work is what is called as power. Simple, right? So this is the formula. Mathematically, this is how you do it. Now, work done, we know that work done is nothing but force into displacement divided by time. So that's how you do it. So because work done by time is the formula for power. Now, what is S by T? S by T is nothing but velocity, because it's the rate of change of displacement. What is that? That is nothing but velocity. So you can write that as F into V as well. This is one more way to represent power. So you can write power as force into velocity, because it's displacement by time. Displacement by time is nothing but velocity. Or you can directly write it as work done by time. Right? So far so good, people. Yes. And again, the SI unit is nothing but joules per second, which is nothing but watt, and the CGS unit is nothing but ergs per second. Right? Awesome. All right, guys. Clear so far? Anyone who has a doubt so far? We will work done complete. Power was done and done. Everything done and dusted so far. With that said, let's get back to the Mentimeter again. All right, let's go. So here's your first leaderboard. By the way, people, I forgot to show you the leaderboard. 24 of you guys were able to give the right answer. Now, all of those who have not joined the Mentimeter yet, quickly join it. So, Prasoon attending second physics class. Good to know, buddy. Such dedication. Common Ash. All right. Rishabh Naman, Heartstorm. Then we have Avinash, the line leader. Palaji, Karl, Gaustav. All right, Jai Shri Krishna, high five to you, did Vedant and Rifa as well. What amazing names you people have. Such creative minds of the century. All right, people, so quickly join the Mentimeter again. I'll give you 10 seconds. All those who have not joined it yet, quickly join it. Come on. All right, people, quickly. Come on. Exactly, Boone. Exactly. Because it's displacement by time. No, displacement by time is nothing but velocity. You guys already know about that, right? So yeah, that is the answer. Awesome. Code is 6242696. All right, 6242696 is the code. So quickly join it, people, so that we can move ahead. All right, sounds good. Okay, I'm going to start ahead. I'm going to start with the second question, people. Here is your second question. Take a look at this one. A simple one again, but do it with your own effort. An energy of 4,000 joules causes a displacement of 80 meter in 4 seconds. Calculate the power. An energy of 4,000 joules causes a displacement of 80 meters in 4 seconds. Calculate the power. Your options are 100 watt, 1000 watt, 500 watt, or 320 watt. Let's go, people. Come on. What do you think is the right answer for this question? Again, thank you, Ali. Thanks a lot for that, buddy. So the code is this, people. 6242696 is the code. So quickly join it. Yes, let's go. Is it, Ali? Let's see. All right, all right. So people, before we move any forward, let me tell you this, that I've been sick for the past couple of days. So my throat is starting to itch a little. So if in case I lose my voice or something, please forgive me. I've been sick for the past couple of days. So I wanted to say this in the start, but I completely forgot about it. I was so excited to meet you guys after a long time, but right now I'm starting to feel the itch. So if in case I lose my voice or something, please ignore it. I'll try to keep it as clean as possible. All right. So anyways, 23 of you guys went with option number B for some reason, and that is apparently the right answer as well. Congratulations, people. Congratulations. Well done. So how do you solve this question? It's pretty easy. It's pretty easy, people. So energy is given. So energy of so I'll consider. Okay. So the formula is very simple, guys. You can see that energy is nothing but energy is equal to power into time. if you remember, one of the formulas of energy is nothing but power into time. All right. So we can see that energy is given as 4,000 joules. So you can do it this way: 4,000 is equal to power into time is 4. So power is equal to 4,000 divided by 4. So 4 1. You can do it exact. This is like a 2-step answer. Directly put on the equation. What is the energy is equal to power into time, and get the answer as 1,000 joules. I do not think that where do you guys go wrong? Did you guys forget the formula? Did you guys get the calculation wrong? What I don't think calculation should have been calculation mistake should have happened. It's just 4,000 divided by 4. Anyone can do this. It's 4,000 joules would be the right answer, no doubt about it. But still, people remember the formula: energy is equal to power into time. So remember that one formula as well. So there are 3 formulas that you remember. One is work done by time, one is force into velocity, and the third is nothing but this formula, that is energy is equal to power into time. So these 3 things, right? All right. So now joules, what? All right. So yeah, what did I write? Did I write it as joules? Oh yeah, sorry. Sorry. I read it as joules. It's not joules, people. It's what? Thank you, Avinash. Thank you for correcting me. Alright, people. So, anyways, here's your leaderboard. Ash on the top, Avinash on the second, Naman on the third. Shreya was the first to answer. Parleji, then Rifa, Pikachu. Then it's Amit, Sam, and Vedant as well. Congratulations, people. With that said, let's get back to the next topic, people. Let's quickly finish it off as well. So that is the answer for this question. Direct answer. You can also do it this way as well. You can write it as because energy is nothing but work, so you can do it this way also. Force into displacement. You can do it this way also. Here they've used displacement instead of time. So you can do it this way also. You can do it this way also. Whichever way you're comfortable with, whichever you feel you can remember it better, do that. There is no there's no hard bent rule that you have to follow my method itself. You can do it any way you want. All right. Ultimately, you have to get the right answer. That is all that matters, right? So that is it, people. With that said, let's get back to the next topic, which is nothing but energy. So just give me another 5 more minutes. Let's quickly finish it off and get back to the quiz. Energy. What is energy? Energy is nothing but the capacity to do work. That is what it is. That is how you define energy. For you to do something, for me to move my hands, for me to stand up, for me to talk, you need energy. And this energy that enables you to do work, or the capacity to do work, that is what is called as energy. The thing that helps you to do work, that is what is energy. Now the SI unit of energy is the same as that of work done, which is nothing but joules. The CGS unit is erg itself. The higher units of energy, however, is watt hour and kilowatt hour. And how did you come to that conclusion? Remember this, people. Again, energy is nothing but power into time. So the SI unit of power is nothing but watt, and you can take the higher unit of time is nothing but hours, not seconds, hours. So you can write it as watt hour, and the higher unit of watt is kilowatt, so you can write it as kilowatt hour as well. So these are all the higher units of energy. So you have joules, erg, which is the CG's unit, and then watt hour, which is the higher unit, and kilowatt hour, which is the highest unit of them all. So generally, people remember this, that in your electricity also, when we calculate units, when we calculate the higher power consumption, or the electrical energy consumption and all that, we calculate it in terms of kilowatt hour, because that is the highest, that is basically the highest way of, or the biggest unit that we have. So kilowatt hour is the biggest unit that we have. So remember this, people. 1 watt is equal to 1 by 1000 kilowatt, or you can say that 1 kilowatt is equal to 1000 watt. Any way you want to remember it that way. So remember that as well, because these things will help you to do questions. When you're solving these questions regarding electricity especially, you'll be able to, it'll be able to help you out. So these are all the the conversions. So 1 watt hour is equal to 1600 joules. Why so, if you may ask? So again, people, 1 watt hour is nothing but 1 into 1 hour in terms of seconds is nothing but 3600 seconds, because it's 60 into 60, so 3600. So you'll need as 3600 joules. And 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joules, or you can write it as 3.6 megajoules, which is nothing but 10 to the power 6 itself. So 10 to the power 3.6 into 10 to the power 6 joules, or 3.6 megajoules is how you convert 1 kilowatt hour in terms of joules. 1 calorie is 4.118 joules, and 1 electron volt is equal to 1.6 into 10 to the power minus 16 joules, because you don't remember that 1 coulomb is equal to 1.6 into 10 to the power minus 19. 1 one electron has a charge of 1.6 into 10 to the power of minus 19 joules, coulomb. So here also it will be the same thing, just that in place of coulombs, you have to write it as joules. So it will be 1.6 into 10 to the power of minus 19 joules, right? So these are all the conversion. Now I know that many of you guys might be thinking, sir, why do we need all this? Again, people, you never know. Sometimes they might just surprise you by asking you a weird question like this. So it's important to remember all of these. At least a few conversion is very important that you remember. 1 watt or 1 kilowatt or 1 calories and all that. Remember it in calories, though you will have to do it in calorimetry again. Heat wala chapter, you'll have to do it again. So better remember it right now itself, so that it'll be much more easier when you go there, right? So yeah, with that said, let's get back to the topic. So the types of energy, people. One of the most common questions that you have. What are the types of energy? Now, people, there are different types of energy. Now, remember, guys, that energy can be in pretty much all forms. So we have mechanical energy, which is a combination of both potential and kinetic energy, which we'll be studying later on. So I'm not going to explain that right now. Light energy is the energy that enables you to see things. Heat energy is the energy that transfers from hot objects to cold objects. Thermal energy is again somewhat related to heat energy itself. That is because of the entropy or the randomness in the system. Nuclear energy is because of nuclear fission and fusion. Wind energy is the the movement of the wind, which can be used or which can be harnessed into electrical energy. Electrical energy is nothing but the flow of electrons. Hydro energy is nothing but the water that is stored in the dam falling down the movement of the water particles getting converted to electrical energy. Again, solar energy is nothing but the light, that is packets of energy called as photons, getting converted to electrical energy. Chemical energy is the energy that you have in your batteries and all of that. So people, again, you don't have to remember all of these. It's not it is not necessary that you remember all of these and define all of these, but they might ask you at least explain 5 forms of energy, or define 5 forms of energy, or state 5 different forms of energy or types of energy. That way you'll have to remember a couple of them, like nuclear, thermal, wind energy, solar energy. Remember at least 5 of them, because that will definitely help you out in those 1 mark and 2 mark questions. It will definitely help you out, right? So once again, people, what is energy? It is nothing but the capacity to do work, and energy can be in different forms. These are all the different forms. We have other energy also. We have geothermal energy and a lot more as well. But for now, let's just remember at least 5 of them, because that is what you can expect in your pre-boards or your board exams as well, right? So far good people, all good. Yeah, we'll do the mentee. We'll go back to the mentee right now. Before that, is it clear? Energy is the concept of energy clear, people? In the chat box quickly, because we have only 30 minutes left. Let's do it. Devapita, I believe electron volt to volt you don't have it right now. In 10th standard you don't need it, but in your 12th you might need it. So for now, I don't think that is necessary. Electron volt to volt they won't ask you right now, but in your 12th you might need it. Not right now. So no need right now. All right. Hydro energy is nothing but it's nothing but this. Now, water is stored at a certain height, so it contains potential energy. That energy, when you open the dam, the water that falls down, the potential energy contained in that water particles will get converted into kinetic energy, and that kinetic energy is then used to run the turbines. That is, it is converted to mechanical energy. That mechanical energy is then converted with the help of transformers into electrical energy. So that is what is hydroelectricity. So water at that height contains a lot of potential energy. That potential energy converting to kinetic energy first, kinetic to mechanical to electrical. All right, so that's how it is. All right. Anyways, so this is the third question. People, take a look at this one. Quickly solve this one as well, and then let's get back to the next topic. An electric motor of power 100 watt is used to drive the stirrer in a water bath. If 50% of the energy supplied to the motor is spent in stirring the water, calculate the work done on that water in 1 minute time. I'll read the question again. An electric motor of power 100 watt is used to drive the stirrer in a water bath. If 50% of the energy supplied to the motor is spent in stirring the water, calculate the work done on the water in 1 minute time. Your options are 3000 joules, 2000 joules, 1500 joules, or 4000 joules. Go ahead, people. 30 seconds left. Thank you, Shyam. Thanks a lot, buddy. Thank you. So why energy is what? Why energy is equal to work? Because energy is the capacity to do work. Nah? For you to do something, you need energy, right? For you to, like for example, for me to talk right now, I need to eat food. What does food give you? Food doesn't give you work done. Food gives you energy. And that energy is used up by your body to do work. Ultimately, it is nothing but how much of energy you have, you're spending it to do some work. So it's basically the same thing. Whatever energy you have, you're doing that, you're using that to do some work. So it's Pretty much the same thing. It's pretty much the same thing. Because if you don't have energy, you cannot do any work at all. You cannot, for me to talk, for me to move something. Okay, let's talk in terms of physics. For me to move a table, I need to spend energy on it. And that energy that I spend is helping me to do some work. And what is that work? What is that table is getting displaced. That is what is the work done, right? So ultimately it's the same thing. Energy is the capacity to do work. All right, that's it. All right, anyways, 16 of you guys were able to give the right answer for this question. 3000 joules is the right answer. So how do you calculate this? It's quite simple again, people. So they've given you the power, they've also given you the time taken. All right, first of all, calculate the energy consumption. So energy is equal to power into time. Now I'm going to calculate in terms of joules. So that's 100 into 1 minute. So I'll convert that to seconds. So 60 seconds. So that's 6000 joules is the amount of energy that is, that is used, that is consumed. But the question is, out of this 1000, out of the 6000 joules, they're telling that only 50% of the energy is actually used up. So that means the rest half of it can be lost in the form of heat energy or because of resistance or something of that sort. So how do you calculate that? Very simple, people. So the energy consumed is equal to 6000 into 50 divided by 100, because only so much amount of energy is consumed. So 50 divided by 100, so that's 5630. So 3000 joules would be the answer. Got it? Is it clear, people? Alright, yeah, I'll speak a little slow. I'm really sorry. I just went on. Alright, anyways, so people, that is the answer for this question. So first of all, calculate the energy consumed. Energy consumed is equal to power into time. Power is given as 100 watt and time taken is given as 1 minute. Convert that to seconds because you want to convert that, you want to calculate it in terms of joules. Once you do that, then calculate, because they're telling that only 50% of the energy is used up. So what is that 50% in that 1 minute? That's 6000 divided by into 50 divided by 100. That's something like 3000 joules. Got it? Clear, people? Is it clear? 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 Did you understand? So please answer my sure, Raman, sure. So that is the answer for this question, guys. Congratulations, all those who got it right. For all those who got it wrong, that is how you do it, people. First of all, find out the energy consumed, then find out what does 50% of that total energy consumed really mean in terms of value. What does it mean? Calculated by using that, the percentage wala equation. You guys already know about it, right? Anyways, Common Ash still on top, followed by Naman. I was the first to answer. Congratulations. Shreya, Pikachu, Amit, Rifa, Vedant, Neha, Avinash, and Kritika of class 9th, ICSE class 9th. Congratulations, people. Well done. Keep up the good work. With that said, let's get back into the topic. All right, one more thing. All right, before we go to the next next stop. Before we go to the next question, let me just finish up this one topic as well. Potential energy. Now, people, listen up, everyone, listen carefully. What is potential energy? See, guys, there are two types of mechanical energy. What is mechanical energy? Nothing but the energy possessed by the body due to its motion or due to its state of rest. That is what is mechanical energy. What is mechanical energy? The energy possessed by the body due to its position, due to its virtue of its state of rest or motion. That is what is mechanical energy. Now there are two types of mechanical energy. We have kinetic energy and potential energy. Let's talk about potential energy first, then come back to kinetic energy. Potential energy is nothing but the energy possessed by the body by the virtue of its state of rest, position or shape or size. That is what is called as potential energy. What is potential energy? The energy possessed by the body due to its position of state of rest, size or shape. That is what is potential energy. For example, if I were to lift this pen up, the pen right now is at a certain height in comparison with the ground. With a ground, it is at a certain height, which means that this body contains or possesses some energy. That energy possessed by this pen at this height because of its state of rest, that is what is called as the potential energy of the body. Now in specific, that energy is called as gravitational potential energy. Why gravitational potential energy? Because the force on this object is not the force that I am applying, but rather it is the gravitational force that is trying to pull the body down. So this energy that is possessed by the body at a certain height with respect to the position of the earth, that is called as gravitational potential energy, or in simple words, you can call it as potential energy. Now, this is not the only form of potential energy, people, remember that, but this is how you define it. Potential energy possessed by the body due to its position related to the center of the earth. From the center of the earth, what is the position of that body? That is what is called as gravitational potential energy. Now, again, it is not always necessary that the potential energy should be with respect to the center of earth itself. For example, if I were to keep for example, let's say that I keep the pen on the computer right now, and I lift it up. Here the potential energy possessed by the body is with respect to the computer, not with respect to the center of the ground. So remember this, people, it's about the position of the body with respect to something. It could be with respect to earth, it could be with respect to a table, it could be with respect to anything for that matter. But that energy possessed by that body, that is what is potential energy. And more importantly, gravitational energy is nothing. Gravitational potential energy is the energy possessed by the body related to the position of the center of the earth. From the center of the earth, what is its position? That is gravitational potential energy. For example, guys, let's say I have a ball, all right, and it has a mass m. And I'm supposed to lift this ball up and keep it on top of this pillar, you might call it as a pillar. So at the ground, let's say that the potential energy, it does not contain any energy at all. It does not contain any energy because it's on the surface of the earth. So from the surface of the earth, what is the height of the object? 0. So you can say that the energy possessed by the body is 0. But when you lift it up and keep it at that height h, when you lift it up and keep it at the height h, in that case, people, what would be the work done? Work done would be the force of gravity applied on the object. Because what is work done? Force and displacement. So here, what is the force? That is nothing but the force of gravity, or nothing but the weight of the object which is acting downwards. And what is the displacement? Is nothing but h. So work done is equal to force into displacement. Now here, the force is what? It is nothing but the weight. So what is the formula for weight? Mass into acceleration into gravity. And what is the height? It is, the displacement is not h, it is not s, but it's h. So the formula becomes mgh, the work done, or you can say that the potential energy is nothing but work done over here on this particular box. So when you're doing it, when you're lifting the ball up and keeping it on a pillar, what are you doing? You're spending some energy, you're doing some work, and that energy that you're spending on it gets stored inside this ball. And how do you calculate it? The formula is mgh, which is nothing but the potential energy. Did you understand this, people? Are you able to understand this? Are you able to understand this? Am I having a one-way conversation? Are you able to understand this, people? So what is happening is that I'm doing some work. I'm doing some work and keeping it on the pillar. When I'm doing some work, I'm spending some energy, and that energy that I'm spending gets stored inside the ball. It gets stored inside the ball. How do you calculate that energy? It is nothing but U is equal to mgh, which is nothing but the potential energy. Got it? That is how you calculate, people. That is the formula. That is nothing but mgh. So the work done is lifting the ball and lifting the body up. It is stored in the body. What is the work done that I'm doing? I'm spending some energy on it. That energy, the work done that I'm doing, gets stored. The energy gets stored inside the ball in the form of gravitational potential energy. And the formula to calculate it is nothing but U is equal to mgh, where U is nothing but the potential energy, m is nothing but the mass, g is the acceleration to gravity, height is nothing but the h. So another example, if you would like to if you want to understand it better, so there are two elephants over here. One elephant is standing on the ground, whereas another is standing at an upper pedestal. So here again, think about it, people. Here the elephant is standing at a height h, whereas this elephant on the other hand is standing on the ground. If both the elephants were on the ground itself, then the gravitational potential energy would have been the same. The gravitational force acting on it would have been the same. The gravitational potential energy would also have been the same. In other words, it will be 0 because the height from the ground is 0. But then because this elephant is at a height h, it will have higher gravitational potential energy or more gravitational potential energy. Why? Because it is at a height h in comparison with the ground. Right? Most relatable example. That's all. That is it. So that's how you understand it, people. So when the body is released from a height, it falls down again. Why does it fall down? Because it contains some potential energy, and that energy, when it falls down, gets converted to kinetic energy. Because as it is moving, when the object starts to move, that potential energy possessed inside of it starts getting converted to kinetic energy. And what happens is that that potential energy keeps on decreasing, and just before it hits the ground, the potential energy becomes 0, and hence, people, you can say that the there's conservation of energy happening. That is, the total potential energy at that height is getting converted to kinetic energy just before it hits the ground. So people, again, if you want to talk, just to give you another example, people. So imagine that I have a ball. Now this time I'm lifting up the ball to this height first, and again one more ball I'm lifting up to another height, alright, which is much more higher than the first one. So this is h1 and this is h2. Again, here what is the gain? What is the gain in potential energy? Or you can say that I'm moving this ball from here, whichever way you want to do it. Either I can take the same ball and move it to another pillar which is much more taller, or I can just move this ball from here to here. In that case also, what is the gain in potential energy? It is nothing but the final potential energy minus the initial potential energy, which is nothing but mgh2 minus mgh1. So I can say that it's mg into h2 minus h1. This would be the change or the gain in potential energy. So PE or potential energy is equal to mg into h2 minus h1. Again, how much is the difference in the potential energy? That is what I'm trying to prove over here. I'm trying to show that there is a clear difference. As the height is increasing, there is a change in potential energy, and I'm trying to prove that mathematically by showing that the height is different, h1 and h2, and again there is a slight change in the potential energy gained as well. Right? So yeah, people, that pretty much concludes your potential energy as well. One more thing is the next thing I would like to talk about is the elastic potential energy. Like for example, in a string, like if you have a spring like this, or a string or a spring like this, what would happen is that when you expand the string, you have to apply some energy. And as soon as you leave it, what will happen? It will come back to its initial position. So here also it contains potential energy. When you expand it at its maximum distance, when you expand it like that, it contains potential energy because it's in the state of rest. As soon as you leave it, what will happen is that potential energy gets converted to kinetic energy and it will come back to its initial position. This is called as elastic potential energy. Now here again, people, you don't have it right now. You don't have to read too much. You don't have to learn too much about it right now, because you will be studying about this in your higher grades. But just to give you a hint, what is the formula like for this one? So again, here also the potential energy will be half into K delta x square, where K is nothing but the spring constant and X is nothing but the displacement of the spring. That is what it is. The displacement, what is the initial position and what is the final position. The change in the delta stands for change. What is the change in the position? That is what it tells you. So U is nothing but, here you can write it as UE, that is the elastic potential energy, is equal to half into K delta x square. Now again, you don't have this right now. This is not needed for you people right now. You'll be studying about this in your 12th grade. But if you're asked about elastic potential energy, is nothing but the work that is you can say the energy that is stored in the string when it's in its extreme position. That is what is called as your elastic potential energy. Simple. That is what it is. All right. So you're doing some work again. You're doing some work. When you expand it, you're doing some work. And what is that? What is happening? The work done that you're doing, the energy gets stored inside the spring, and that is what keeps it in its position. And as soon as you leave it, what is happening is that the energy gets converted to kinetic energy and it moves towards each other. Right? So yeah, people, once again, that is how you do it. So this is the gravitational potential energy definition. The potential energy possessed by the body by the force of attraction of the earth, or by the virtue of its state of position with respect to the center of the earth. That is what is gravitational potential energy, represented as U. Formula is mgh. And the SI unit is again joules itself. In the case of elastic potential energy, the energy possessed by the deformed state due to the change in the size or the shape, or size and the shape, that is what is the elastic potential energy. Yeah, with that said, let's get back into the quiz again. We've been talking. So people, I know it's been a one-sided conversation, because people, I only have 10 minutes left and we have a lot more to do. That's why I'm rushing it up a little. So please bear with me, because we have kinetic energy and a lot more to do. So quickly join the mentee meter. All those who have just gone out, quickly join it. The code is 6242696. That is the code. Quickly join, people, and then we'll move on to the next question. Come on, quickly. String or spring, you can see that it's not necessary that it has to be a spring itself. In the case of a string also, it's the same thing. Like in the guitar string also, it's the same thing. Again, you see that there's elastic potential energy, because again, it keeps on going to and fro, and again comes back to its original position itself. It does not get completely displaced. It does not get it does not get thrown away, right? Every time you string a guitar, it's not like it's getting thrown away. So it's pretty much the same thing. All right, don't worry. All right. No, Divya, I'll check it. I'll check it after the session. I'll check it after the session. So yeah, people, go ahead and solve this question. I'm going to start the quiz now. Here is your fourth question. Go ahead and do it, guys. Come on. Oh, is it Rima? Oh, alright. No wonder. Alright, here's the question. Two bodies A and B of equal masses are kept at height 20 meter and 30 meter respectively. Calculate the ratio of their potential energy. Such an easy question. What is the ratio of their potential energy? Options are 1:3, 2:3, 3:2, or 1:2. Let's go, guys. Come on. Alright, done? Alright. What is the name of my haircut? I have no idea now. Sure, no worries. Alright, 20 more seconds, people. Such an easy question. Let's go ahead and do it. Two bodies A and B of equal mass are kept at height 20 meters and 30 meters. Calculate the ratio of their potential energies. Come on. I don't know, Dash. Easy question, no? That's fine. Just to give you an idea. What kind of questions you can expect. Exactly correct, people. The right answer is 2:3 itself. 28 of you guys were able to give the right answer. Once again, no doubt, it is 2:3 itself. How do you solve this? It's quite simple, people. Again, they've given you the height. So first of all, you can take it as U1. U1 is equal to m. The mass is same. Obviously, the acceleration of gravity acting on the body would also be the same. So mgh is the formula. So mgh1, we'll take it as mgh1, and u2 is equal to mgh2. Mass is the same. Acceleration of gravity is the same. In a particular place, acceleration of gravity will not change. So that's the same thing. So again, what is u1? U1 is equal to m into g into 20, and u2 is equal to m into g into 30. So divide u1 by u2. You will get it as mg20 divided by mg30. mg gets cancelled, so 0 gets cancelled, so you get it as 2/3, which is nothing but 2:3. That's all, right? That is the answer for this question. That's all, people. That's all. With that said, let's get back into the topic. Let's quickly go on to understanding about kinetic energy next. All right, because we have a lot more to do, and I don't have much time. So let's quickly do this, people. Kinetic energy. Now, potential energy is the energy possessed by the body by the virtue of its state of position, or by the state of its rest. State of its rest, yeah. State of rest. Kinetic energy is nothing but the energy possessed by the body by the virtue of its state of motion. When a body is moving, the energy possessed by that is what is called as kinetic energy. Alright, so if you define what is kinetic energy is possessed by the body equal to the amount of work which moving body can do before coming to rest. For example, when you kick a ball, when you kick a ball, the ball is going and doing some work on this particular glass. What's happening is that it's breaking the glass. So there's some work done on the glass. So what is the amount of work? So it obviously possesses some energy. For it to do some work, it has to have some energy. So here, the kinetic energy can be defined as what is the work done while it's moving before it comes to a state of rest. That is what is your kinetic energy. Now, another example for this, we can give the example of cricketer catching the ball. So when a cricketer like for example a wicket keeper, when when a ball comes towards them, what do? They catch the ball, and sometimes they move a little backwards in order to stop the ball, in order to bring the ball to a state of rest. So kinetic energy is equal to what? The retarding force, that is whatever force that is applied by the wicket keeper in order to stop the ball, into the displacement of the ball. So here the kinetic energy is equal to F into S again, and retarding force is equal to M into A, that is the force applied is equal to M into A. So what you can do is solve for S over here by using the third equation of motion, that is V square is equal to U square plus 2AS. Now the initial velocity of the ball is, we can consider the initial velocity as V, and the final velocity as 0, because the ball is coming to a state of rest, because you're applying a force. That is the retarding force. You're applying a force in order to stop the ball, right? So that is the force that you're considering over here. So F into S. So I'm trying to find out what is S. F is equal to M into A. We already know that. S I'm trying to find out by using the third equation of motion. V square is equal to U square plus 2AS. So initial velocity U is equal to V, which is the final velocity, which is 0, because the ball is coming to a state of rest. So if you substitute the values over here, so 0 is equal to V square plus 2AS is what you're going to get. So solve for S. So S is equal to V square divided by 2A minus V square by 2A. I think, okay, did I make any mistake? Wait, initial velocity is V. This is 0. V square. So you'll get as S is equal to minus V square by 2A. I believe that is a, yeah. Wait a second, guys. I think I made a mistake over here. Huh? All right. Oh yeah, exactly, guys. I didn't take the acceleration. Acceleration is minus a over here because it is retarding. No, it's a retardation force. It's coming to a state of rest. So it's minus a, not a. So you can take it as minus a over here because it's coming to a state of rest. So it will be minus a. So it will be plus. We didn't take it to the other side. It will be plus. So s is equal to v square by 2a. Substitute that over here. So we'll get it as what? Ke is equal to ma into v square by 2a. A gets cancelled. So you'll get it as ke is equal to half mv square. So this is your formula for kinetic energy, people. So that's how you can. This is one more way to calculate it. Either you can do it like this, or you can also go with the derivation that is given in your textbook as well. So this is one more way to calculate it. So here the displacement is s, initial velocity is v, so u is nothing but v, final velocity is nothing but 0. The acceleration is retardation, so it's minus a. That is where I made the mistake. So v square is equal to u square plus 2a, and 2a is, substitute that over here, you'll get as s is equal to v square by 2a. Substitute that in the first equation, that is force is equal to what is that? Work done is equal to force of displacement. In place of displacement, put it as v square by 2a, and you'll get the answer as half mv square. Right? So this is one more way to do it, people. This is one more way to do it. Yeah, I'll be doing that also. Don't worry, Madhu. I'll be doing that as well, people. So this is the formula to calculate kinetic energy. So kinetic energy is equal to half mv square. So again, remember this, people. So kinetic energy is directly proportional to the mass and the velocity. So the velocity increases, the kinetic energy increases. If the mass increases, the kinetic energy also increases for that as well. Greater the mass, greater would be the kinetic energy. Greater the velocity, greater would be the kinetic energy. The faster the body is moving, the more would be the kinetic energy. The slower the body is moving, the slower would be the kinetic energy. If the mass is kept constant. If the mass is different, again, if the mass is more, kinetic energy is also going to be more. If the mass is going to be less, the kinetic energy is going to be less. Now, for all those who are asking, so what is the relationship between kinetic energy and linear momentum? So let me just solve this for you guys. I'll just, okay, yeah, I think there's no space for me to do it, so I'll do it over here itself. So kinetic energy is equal to half mv square. So kinetic energy is equal to half mv square. Now, what I'm going to do is I'm going to multiply and divide this equation by m. Alright, so multiply this equation by m, so it will be half m square v square. So I'll take this as 2m whole divided by 2m. So I can remove this 1. I can write as m square v square by 2m because I'm multiplying it and dividing by m. Now what is m into v? M into v is nothing but momentum, which is nothing but p. Momentum is nothing but the quantity of motion or the quality of motion or the amount of motion that is possessed by the body. That is what is momentum. So m into v is nothing but p. So I can write this as p square. M into v is nothing but p. So I can write this as what? mv the whole square. I can write as mv the whole square. M into v is nothing but p. So p square divided by 2m is what you're going to get, which is nothing but which is equal to kinetic energy, which is taken as k. Now take this to the other side. So p square is equal to k into 2m or 2km. You can take it like that. So p is equal to root of 2mk or 2km. Whichever way you want to do it, you can do it like that. It's such an easy derivation. All you have to do is multiply and divide the equation by m. That is all you have to do. And in place of mv, you can take it as p, which is nothing but the momentum. So this is the relationship between momentum and kinetic energy. The relationship between kinetic energy and momentum is this: p, which is the kinetic, which is the momentum, is equal to root of 2 into mass of the body into the kinetic energy. Got it, people? Is it clear? Yes, yes, we'll be doing the mentee also. Is it clear, people? Is it clear so far? Did you understand this easy peasy relationship between kinetic energy and momentum? Is it clear? Yes, that's it. All right, people. That's all. All right. Moving on, people. Moving on. So this is the definition. If a massive particle and a light particle. Okay, this is one more thing. If a massive particle, if a body which has more mass and a body which has less mass, a lighter particle, have the same momentum, that is p, then the light one will have more kinetic energy. Even if we talk in terms of momentum, then the one which is lighter will have more kinetic energy. But if you talk about in terms of velocity, that is, if the lighter particle and the heavier particle have the same velocity, then the kinetic energy for the heavier particle would be more. So you have to understand the relationship once again. So if you consider in terms of momentum, the lighter particle and the heavier particle, if you consider the momentum of both of these, the lighter particle will have more kinetic energy. If you consider in terms of velocity, if the lighter particle and heavier particle have the same velocity, in that case the heavier particle would have greater kinetic energy. Again, from this relationship itself, so P is equal to root 2 mk. So in this case, again, remember this, people, if you talk about in terms of momentum, the lighter particle will have greater kinetic energy. If you talk about in terms of velocity, the heavier one would have greater kinetic energy. All right, so remember this one small thing as well. It is a small relationship, but it's also very important as well. Now to talk about work energy theorem, people, this is also quite simple. Work energy theorem simply states that the increase in the kinetic energy is equal to the work done by the body. Now I'm going to show you how to do the relationship, how do you derive this equation. But remember this one statement, people, the increase in the kinetic energy or the change in kinetic energy is equal to the work done by the body. That is what is your work energy theorem. So how do you do this? It's quite simple. Once again, we're going to consider a small body of mass m with an initial velocity u. You're applying a force F, and again, this is the final velocity v. Again, you're applying the force F itself. Displacement is s. Now here again, we're going to consider, I don't have space, so I'm just going to do it over here itself. So force is equal to mass into acceleration. Now what is work done? Work done is equal to force into displacement. So we're going to consider again the same thing that we did before itself. So mass into acceleration into displacement is what you have. Solve for s once again. Find out the displacement. So using the third equation of motion, v square is equal to u square plus 2as. Find out for s. So you will get it as 2as is equal to v square by 2a. So you can write this equation as you can write it as, we can just keep as it is. As is equal to v square minus u square divided by 2. This is what you're going to get. Now what you're going to do is, after this, multiply both the sides by m, both the sides on left hand side and the right hand side, multiply it by m. So you will get the equation as m into a into s is equal to v square minus u square divided by 2 O into m. Now m into a is what? Mass into acceleration, nothing but force equal to mass into acceleration. F into s is equal to you can write it as mv square minus u square divided by 2. So mu square divided by 2. Now what is half mv square? So you can you can write this as f into s is equal to half mv square minus half mu square. What is this? Is nothing but the kinetic energy. So there is nothing but the change in kinetic energy. So the initial velocity and final velocity is what you're taking. So final minus initial divided by 2. In other words, it is a change in kinetic energy. So this represents the change in kinetic energy. So force into displacement is equal to change in kinetic energy. What is force into displacement? Is nothing but work done. So work done can be written as the change in kinetic energy by using this particular equation. Got it, people? I know I am not supposed to I don't have enough space, or else I would have done it myself, but there's not enough space. So quickly, people, this is how you do it. Again, this is the work energy theorem. So this theorem states that change in kinetic energy is equal to the work done. Once again, how do you solve it is, we know that force is equal to mass into acceleration. We know that work done is equal to force into displacement. In place of displacement s, I am going to substitute the third equation of motion. V square is equal to u square plus 2as. Find out for s. So when you find, like, basically take all the take 2 to the other side. So you'll have as on one side is equal to v square minus u square divided by 2. Now multiply both the sides with m. This is one step that you have to add. So multiply both the sides with m. So ma into s, which is m into a, is nothing but force. So force into displacement is equal to mv square minus mu square divided by 2. You took m into inside the brackets. So you'll get as mv square minus mu square divided by 2. So what is mv square minus mu square divided by 2? That is nothing but the change in kinetic energy, because that is nothing but this. It is nothing but half mv square minus half mu square. So it is nothing but the change in kinetic energy. So you can state that the work done is equal to change in kinetic energy. Got it? Is it clear, people? Did you understand this? Is it clear? Is it clear? There's not enough time. That is why I'm rushing it up really fast, because I have another session at 6. So there's not enough time for me to complete the topic. That is why I'm rushing so fast right now, people. I have to go through it because there's another session I have at 6. That's why I have to rush it up a little. So quickly, people, let me just quickly take you through all of this. There's a little bit more left. So types of kinetic energy of 3 types: transitional, rotational, and vibrational. Transition, nothing but the kinetic energy possessed by the body which is moving in a straight line. Rotational kinetic energy is the energy possessed by the body when it's rotating about an axis. Vibrational kinetic energy is the energy possessed by the kinetic energy possessed by the body when it's going to and fro about its mean position or its position. That is what is called as your vibrational kinetic energy. You talk about a string, a string of a guitar. It goes back and forth or to and fro about its mean position. That is what is called as. That also contains kinetic energy. We have already seen that. So that is a string kinetic energy. The string kinetic energy that we string kinetic energy that we have. Vibrational kinetic energy that is possessed by the body. That's it. All right. So people, let's quickly do this quiz question as well, and then let's finish off this topic now, because again now there's not enough time. I have only 5 minutes left, and there's a lot more to do. So let's quickly do this question and then get back to the topic. So people, just this is one more question, the fifth question. Sorry, quickly do it, people. I'm going to start the quiz right now. Just go ahead and solve this question. Come on. A moving body weighing 400 Newton possesses 500 joules of kinetic energy. Calculate the velocity with which the body is moving. Take g is equal to 10 meter per second square. So they have given you the weight as 400 Newton. It possesses 500 joules of kinetic energy. Calculate the velocity with which the body is moving. Take acceleration due to gravity as 10 meter per second square. Options are 5 meter per second, 10 meter per second, 0.5 meter per second, or 2.5 meter per second. Let's go. All right. Okay. Quickly, people, quickly. Sure, Ayush, you'll be getting the PDF. People, don't worry about it. You'll be getting the PDF at the end of the session. I know. Is it? I have another session right after this. I have a regular session, so I have to quickly go back into that as well. So that is why I have to rush it up, people. So quickly. 30 more seconds. Quickly do this, people. Come on. Yeah, I have a session at 6. So we have 5 minutes left, people. I think I'll not be able to complete the whole thing today. I don't think I'll be able to complete it. I'll see if I can record the rest of it and put it up, as a video per se, because I will not have time to complete this, people, because there's not enough time left. But nonetheless, 11 of you guys were able to give the right answer. Congratulations. So how do you solve this question? It's quite simple, people. Again, kinetic energy is equal to half mv squared. Kinetic energy is given as 500 joules, so 500 is equal to half. Mass is given as 400 Newton. So they've given you in terms of weight, so calculate the mass. So remember this, guys, weight is equal to mass into acceleration to gravity. So mass is equal to weight by acceleration to gravity. So that is 400 divided by 10. So that's 40 kgs. I'm pretty sure that a lot of you guys would have gone wrong in this one. This is where majority would have gone wrong. You directly took it as 4. This is the weight. They've now given you the mass. So how do you calculate the mass? Divided by the acceleration to gravity, so you'll get the mass. So 40 kg is the mass. So 40 into V is nothing but what you have to find out. So this is a 1000 to taking 2 to the other side. So that's 1000 divided by 40 is equal to V square 0.04284,520. So 25 is equal to V square. V is equal to root of 25, which is nothing but 5 meter per second. That's all right. So this is where majority would have gone wrong, where you did not calculate the you did not consider you directly put down as the mass. That is not the mass, people. That is the weight. So in order to calculate the mass divided by acceleration to gravity, which will give us 40 kg. All right. So yeah, people, we have, I think, 1 second, people. Let me just see if I can complete this. I don't think we have enough time to complete this. Principle of conservation of energy. I don't think we'll have enough time to do this. So people, is it okay if we just stop it right here for now? And I'll do the rest of it as a recording. I'll premiere it probably by today or by tomorrow. We'll premiere that as well, because there's not enough time for me to go through the derivation. I'll be just rushing it up. I'll be just talking, like really fast. So there's no point in doing that. So yeah, pendulum is also, don't worry, I'll be doing that. But right now there's not enough time for me to solve it. I will do that and put it up as a video. Just this part, principle of conservation of energy, and about the pendulum, about this derivation. This is a very important derivation. I'll be doing this also, but I don't have enough time to do it right now because I have another session. So I will do the rest of it in the next one. Principle of conservation of energy. I'll do it in the next one. Until then, people, sorry for that I could not complete the topic, but yeah, we just don't have enough time to do it. But nonetheless, guys, here is your final leaderboard for today as well. The rest of it, I'll be doing it as I'll record it, I'll premiere it. Don't worry, people. It'll be premiered by today or tomorrow. I'll try to premiere that as well. So this is your final leaderboard for now. Enjoy yourself, people. Naman is the winner for today. Congratulations. Followed by Shreya, followed by Pikachu. Then it's Vedantu, Amit, Kushi, Palaji, Rifa, Sam, and Neha. Congratulations. Well done. So that's it for now, people. I really don't have time. There's only 2 minutes left. Thank you for joining. Thank you for all the love and support. I will see you guys in the next one. Yeah, and I am sweating a lot because I'm under stress to complete the topic on time, but I could not do it even after rushing so much. I still wasn't able to complete the topic, so I'm a little worried about that. But don't worry, guys. I'll be doing this as a separate session. We'll do this. The rest of the topic that is left out, I will be doing it soon. I'll be premiering that part alone in the next one. So look out for that. Subscribe to the channel so that you're aware of it, people, and hit the bell icon as well. Thank you for joining. I'll catch you guys in the next one. And yes, heat will be starting this week. This week we'll be starting off with heat as well. I think we'll be starting off with calorimetry, and then we'll go on to latent heat as well. So first we'll start off with calorimetry. I think we'll be starting it this week. This week we'll be starting off with heat for ICSE 10th. Yeah. That's it, guys. That's it for now. Thank you for joining. I'll see you guys in the next one. Take care. Stay safe, guys. Bye bye, people. Bye bye. I know there's one more question, but there's not enough time to solve it now. I'm really sorry. There's not enough time to solve it. I have to take leave now. I have another session to go to. So really sorry about it, but I'll see that we can, if we can do it some way or another, I'll try to do that as well. Don't worry, people. So thank you for joining. I'll see you guys in the next one. Do not forget to like the video. Do not forget to subscribe to the channel. Catch you guys in the next one. Until the next time, this is Anoop signing off for the day. Bye, bye, people. Take care of yourselves. Stay safe. And have a great evening. I hope at least you were able to understand so much. Whatever we have done, I hope you guys were able to understand. If there is any doubt, you can reach out to me at anoop.manoran@vedantu.com. You can reach out to me on this email ID. So thank you for joining. Catch you guys in the next one. Bye bye for now, guys. Take care of yourselves. Stay safe. Bye guys. Take care. Bye bye.